Okay, the purpose of this problem is to get you looking at things in multiple manners. So they asked us to look at the table, which is a numeric approach, the graphing utility to graph it, so we're looking at a graphical approach, and then C, solving the equation algebraically. If you're actually able to describe that verbally, you'd have what I call the rule of four: graphical, numerical, verbal, and algebraic. So the first part says complete a table. So one thing I'm going to do is on my calculator, I'm going to make sure that it is set up, table set says ask for the independent. So it should look something like this. Table start, delta table, doesn't matter. Ask and auto is what matters. Next thing, I'm going to go to my table, second table, second graph, and I'm going to just complete the table like it says. So 5, 6, 7, 8, 9. So what I'm looking for is a value of 500. Okay, and it looks like if we tune in here, it looks like it's in between 8 and 9. So I could actually fill in the table on my paper. Going to estimate somewhere in between 8 and 9. My guess is it's closer to 8, but I don't know that, and actually until I start doing something. So between 8 and 9 would be what I'd say for A. Okay. Now, the next thing it says actually graph both sides to estimate the solution. So I'm going to go to y equal, I'm going to put in my 500. Keep in mind, guys, we're talking about y is 500, so we're window setting. We're saying it's 5 to 9, so I'm going to say, negative 10 to 10 should be fine. But y I'm in, negative 10, I better have over 500 in there for my value, or it's not even going to show up. So I'm going to say 600. I'm going to hit graph. We see the part of the graph, we see the other part. I'm trying to find out that point of intersection right there. So I'm going to try tracing to start with, just to kind of show you. So if I trace, I'm on the first one, which is the crazy one. If I use my down arrow, I'll actually start following the second one, and I can actually get pretty close to that estimate right in there. Okay, looks like about 8.72 is 500. Okay, keep in mind every value on this equation is 500, so it's not the greatest. I could actually zoom and trace, so I'm going to try that. Zoom, I'm going to zoom in, and I'm going to go over to that area. I'm going to hit enter. Whoops, let's try that again. I think I hit a second button. Zoom in. I'm going to go over to that area right in there, and I'm going to hit enter, and it's going to zoom in closer to that, and I can actually get a better feel for the value. And once again, I'm going to hit trace. I'm on the first equation. It shows me right there. If I use my down arrow, I'm on the second equation. I can see that. I can actually get a little closer. Looks like, 8.6, probably 8.6, between 8.61 and 8.67-ish. All right, so I can get a little better there. I can also, using my calculator, go to calc, which is second trace, and I can calculate the intersection. First curve it's already on there. Second curve, I'm going to go over there, and you can see I'm on the second curve, so we're good. And then I'm going to guess, which I'm going to go to that area and hit enter. And the intersection is saying is about 8.63. Okay, so for part B, I can say it's approximately 8.63 by the graph. Okay, and it did say to 3 decimal places, so 8.635 is a better answer. Okay. All right, the last part is solving algebraically. So I'm going to have 20 times 100 minus e to the x over 2 equals 500. So the first thing I'm going to do is divide both sides by 20. 20s will cancel, zeros will cancel, I'll have 50 halves or 25 equals 100 minus e to the x over 2. Then I'm going to subtract 100 from both sides, and I will have negative e to the x over 2 equals negative 75. I'm going to take the opposite of both sides, which is like dividing by negative 1, and then I'm going to change that to natural logs and find ln of 75 equals ln of 75, let's try that again, getting a little carried away here, equals x over 2. Now I can check that because e to the x over 2 equals 75 would be my exponential form. Now simply taking both sides by 2, and I get x equals 2 ln of 75. And if I quickly type that into my calculator, 2 ln of 75, we get x is approximately 8.635, which is our earlier result from our graph as well. Okay, the good thing is that is an exact answer, so I can actually preserve that accuracy if I wanted to. All right, for this problem, we are asked to use the zero or root function or the zoom and trace of the graphing utility to approximate the solution. In class, we haven't done much with the zero or root function. Zeros are x-intercepts, so what I'm going to do is I'm going to, rather than try to find out where these two graphs, y1 equal the left and y2 equal the right, where they intersect, I'm going to subtract 4 from both sides, set it equal to 0, and look at that function as the function and try to find its zero or root. So here I have the equation that I've done, and I'm going to, sorry for the lousy visual there, but I wanted you to see exactly what was going to be in that calculator, including the shadows and everything else. All right, so I'm going to actually hit graph. I'm going to see what this thing looks like. It looks like it's increasing. It looks like my t-value is off my graph, so I have a negative 10 by 10 window. So what I'm going to do is right now I'm just going to try to expand this, maybe 20. I want to see where the x-intercept location is roughly. It looks like it's pretty close to 20 actually, so I'm going to go ahead and change my window to 25 to make sure I'm actually seeing that value. And keep in mind what I'm looking for is this guy right there. Okay, so the next thing I'm going to do is I'm going to find the calculate button, which is right above trace. So I'm going to do second, calculate, and that has the 0. So I'm going to go to 0, which is the x-intercept, and it asks for the left bound. Now what I'm looking for is basically the somewhere to the left of this point. So I'm going to say somewhere over in here as the left bound. So I'm going to move my cursor over somewhere over to the left of that red arrow. I'm going to hit enter. Then it says right bound, so I'm going to move my right cursor over past that point. So it looks something like that. I'm going to hit enter. It's the boundary. I'm going to guess where that value is. I'm going to go over in this region. This just speeds up the process a little bit. It's somewhere around 20-ish. I'm going to hit enter, and it's going to tell me the 0 is about 21.32. So it says accurate to 3 decimal places. So basically at 21.330 years, we have our appropriate value. So t is approximately 21, let's get a little better, 21.330. And we are done with that problem.